Hello everyone, welcome back to Technish. So today we are resuming our Kotlin tutorial series where we are discussing the intermediate Kotlin concepts. Today we will be deep diving into error handling and null safety. It's one of the most important aspects of any backend developer who wants to move to Java to Kotlin, or they are trying to understand that which one will be better in terms of error handling and null safety. Okay, so we will discuss here the null safety features. We will discuss the exception handling. So, as you know, errors are inevitable in software development, right? So, whether it's invalid user input, whether it's network timeouts or unexpected API responses, proper error handling ensures your application gracefully manages these scenarios without crashing. Okay, so Kotlin gives us tools like try-catch blocks and more idiomatic approach in seal classes. Okay, so as you previously understand that you know how to do exception handling in Java is just the same as the same kind of tools will be provided in Kotlin like the try-catch blocks and all. So we can check with a coding example. So let's open the editor and I'll try to show you how we can do that. It's basically I will do is I'll the try, right? Suppose I write a sample function. I write a sample function. Okay. And here there is a try block. This one is a try block, right? So try block we do what? We wrap it with wrap it with try block to the risky code that you have, that you don't know the determination of the current the function that you have, which way it's gonna go and what kind of output it will produce, you don't know about it. So what you do is you put the code inside the try block. Suppose I put inside that is suppose result. Okay, and I will do some risky ops. Okay, so and if it is successful, I'll print okay success. If it is not, okay, what I'll do is I'll do catch. So catch is also something where you are catching the probable exceptions that you have, right? So I can do is I can define the exception. So this exception is the super class. Okay. So this exception is the super class of all the exceptions. So whenever you create a custom exception, you need to you need to extend it. Okay. And you need to do a super keyword use as well. So for that, this is the super, if you want to this is a super class, that is the exception. If you want to change it, I mean if you want to change it to a specific exception, in what case you put as the specific exception here only. Okay, so in that case what I can do is I can write something. Okay, and whenever you have cached those exceptions, you need so your use case requires some of the code blocks to be some this block of code should be executed. Whether or not anything happens, you should execute the block. In those cases, what we do in Java is finally, and in Kotlin also you can do the same. That is, suppose I do executed. Okay, I give a return. So this is just a basic example that I'm showing you because we are not writing anything. So some risky ops has to be there. Okay, some risky ops has to be there in order to, you know, be it functional, and the return has to be, string. So this is how we can create, and this is how we can handle the exceptions. Okay, so first understand this. We put the risky operations inside the try block, and we are catching the exception in the catch block. And whenever you are trying to execute some of the code, that has to be executed no matter what. In those cases, you put finally, okay, that this block of code will be executed. Okay. So it's just a bad example that I've given. Suppose I give a println. Okay. I do a println. So mostly this finally block is done to close resources that are open in the context. So inside anything of this, this scope, okay, inside this, inside this scope, whatever resources that you've opened, suppose it's a file resource, suppose it's a stream resource, anything, file stream, input stream, output stream, whatever has been there, what you do need to do is you need to close this. So that's a, mandatory practice. That's a good practice. It's not entirely mandatory, but it's a good practice. Okay. So we will go for the next one, which is the verbose. That is the how Kotlin uses it. In Kotlin, like sealed classes can model success and failure states. Okay, in a type safety way. Okay, especially useful in functional programming patterns. So I will give you one. I will declare one sealed class. Okay, let's see how it does. So inside the sealed class, in sealed class, I'll define the record and I'll do what out and t. This is a generic programming that you already know that this is a t. This t defines the type, the type that has been coming. So for that, I will define two data classes, that is success, and I will define it as t, that means the type, and I'll define val, and I will define the data as t, and what I'll return is I'll return the result t, okay, for success. Okay, for data class, suppose I'll do failure. Okay, and now what I'll do is I'll do val error, and this will be throwable. Okay, so this will be throwable, and what I'll do is result, and I'll do nothing. Okay, so this is a sealed class that is there. So it's not particularly everything that I'm doing. So it's just that, I'm just trying to show you how it's done. And for this one, it's not the exact syntax that I'm writing. It's just, that I'm showing that how it can be done. So suppose I write a function, process result, and I take a result with the result type as string. Okay. And inside that, I'll do what? When I'll put the result, and in case of re result dot uh, result dot success, what I'll do is I'll do a simple print, and in case of failure, what I'll do is I'll suppose I'm giving you normal print LB. So, and based on that, we can print the result data. Okay, result dot data. Okay, and or we can provide as result dot error dot message. Okay, this is how we can do it. So as you can see that this is the approach which is very much readable and it is very much concise. Okay, this when expression lets you handle the each case cleanly, not worrying about any unchecked exceptions. Okay, so I have not written the entire thing because we have to create a context and we have to write everything. So I'm just telling you how to do it so you can implement it on your own. And in the later context, whenever we'll be building a CLI tool, there we will use everything. Okay. So there you will get some context that how in the use case we are, actually writing clean codes rather than entirely be verbose in everything. So, okay. So that's done. Let's talk about Kotlin's null safety, which is very much important. One of the most beloved features of Kotlin. So you declare whether a variable can hold null using a, uh, you know, this question mark. This avoids the infamous null pointer exception, or as you can call it, the $1 billion mistake. Okay. So suppose you have a well nullable name and it's a type string. Okay, and it can be null. Okay, what I can define is I can define as a null. So whenever I am printing it, so what I can do is I can do nullable name dot, I mean instead of dot, what I can do is give this question mark and dot length. Okay, so this is simple one. It's rather than whenever in Java what you do is you write an optional class, right? In Java you have optional class and you check is is present. Okay, so based on that you proceed. So rather than doing that, you can simply put this one, this uh, question mark will tell you that whether it's a null, whether it will make the entire thing null safe. Okay, and I'll also want to discuss another thing which is very much fancy, that is called Elvish operator. It's not Elvish Yadav. So what is it? So Kotlin gives these Elvis operators which provides a default value if something is null. Okay, so if I define as nullable nullable name, and if I don't provide anything, and whenever I'm doing that, this is the Elvis operator, and here I can provide technish. Okay, so this is the Elvish operator that we you can safely do this. This will provide the default value that if you don't provide anything, it will by default take technish. Okay, so it's very simple. It's very simple. It's rather than writing everything, you can use it very concisely. Okay, and your code will be neat and clean. Okay, now let's discuss what is the let. So there is a concept called let. So this will help you to execute your code only when a variable is non-null. So it's a very concise concept that you can do. Okay, so I'll do what? I'll do let operator. I'll just show you. So if the name is nullable, okay, what I can do is let's put that inside the main only, in the sample only. Okay, if the nullable name, if you want to act on that rather than having the uh, this null check, what you can do is you can write it in a more concise way, that is dot let. Okay, and if it is non-null, I'll do println and I'll write it. That means the blocks value. So this avoids the unnecessary null checks and keeps your code clean. Okay. So for mandatory non-null checks, Kotlin offers require and check functions to ensure the invariance in the runtime as well. Okay. So this is pretty clear. So first we have discussed the kind of tools that is being provided in the Kotlin, that is try catch finally, and after that we have checked how Kotlin is being used in with the seal class, where it can seamlessly check the with the when block that whether it's you are able to it is able to handle the success and failure. Okay, and after that we have discussed what we have discussed the the null check and the null safety operator, and after that we have decided to check the Elvish operator as well, which will give the default parameters. Okay, the default values. After that, at last we have checked the let, that is it will give the it will execute your code like when the when your variables are not null, so it can act on that. And that's a wrap. So we have explored error handling with everything. Okay, I hope this boosts your confidence in writing safer and more resilient Kotlin code. If you find this video helpful, don't forget to like, share, and subscribe. See you in the next video. Thank you. Bye. Happy coding.